Welcome to the deep dive. For anyone who's ever wrestled with database uptime, uh, data consistency, those words can bring on a bit of a headache, right?
Definitely. Keeping data aligned and always on. That's the challenge.
Exactly. How do you make sure it's all perfectly synced, always available, even if, servers hiccup or the network gets shaky?
Hmm.
Well, today, we're kicking off an exciting new series. This is actually episode 1 of our deep dive into MySQL Group Replication and InnoDB cluster technology.
It's a big topic and really important.
It is. Our mission today, a solid introduction to MySQL Group Replication itself. This whole series, it's designed to give you a really clear, comprehensive understanding.
And later deep dives will get into even more specific articles, advanced stuff.
Right. But today, we lay the groundwork. So what's on the table? We'll unpack the core concepts behind group replication.
Yeah, the fundamentals.
We'll look at its pretty powerful automation features, what it does for you.
Which is a lot.
And we'll talk about, compatibility, the
Yeah.
open source side of things too.
And just to mention up front, all the insights we're sharing today are drawn from a great resource over at kedar.nitty-witty.com. So let's get into those foundational ideas.
Okay, let's do it. So first things first. What exactly is MySQL Group Replication at its core?
Right. So MySQL Group Replication, or GR for short, it's essentially a robust, integrated solution. It's built for creating highly available, fault-tolerant MySQL databases.
Integrated, meaning it's not some separate add-on.
Exactly. It's a native plugin, developed,
Mhm.
packaged right with MySQL itself, built in.
Okay, built in. So how does it actually, work its magic? How does it keep data consistent everywhere?
Well, it's basically a practical way of applying something called the replicated database state machine theory.
Okay. Theory. What does that mean for my database?
Think of it like this. Every single change, every instruction to your database. This theory ensures that every server in the group processes those instructions in the exact same agreed-upon sequence.
The sequence is key.
Absolutely. So they all maintain an identical, totally consistent copy of your data. And they talk to each other using message passing, but in what's called a shared nothing setup. Each server has its own complete copy.
Right, no single point of failure there. That sounds really rigorous. Now, you mentioned earlier its consistency relies on a Paxos-based protocol. What's the benefit of that, especially if someone's, fought data drift before?
Paxos. That's crucial. It's basically a super robust distributed consensus algorithm, like a voting system.
A voting system for data.
In a way, yeah. Every change has to be effectively voted on and agreed upon by a majority of the servers in the group before it's actually committed.
Okay, so it needs agreement.
Exactly. And this guarantees what we call atomic and totally ordered message delivery.
Atomic and ordered, meaning?
Meaning no transaction is ever half done, and critically, all servers see all the changes in the exact same definite order. No ambiguity. For you, this practically eliminates horrible things like split-brain scenarios and really shores up data integrity.
Okay, that's a huge weight off the shoulders.
Oh.
You also mentioned multi-source update everywhere replication before. How does that play out in practice, like different modes?
Yeah, this is where it gets really interesting, the flexibility. GR actually offers a multi-primary mode.
Multi-primary, meaning I can write anywhere.
Precisely. You can write to any server in the group simultaneously. That gives you fantastic write scalability for high throughput stuff.
But doesn't that risk conflicts? Like two people trying to book the last airline seat?
It can, yes. You need to think about application design there. But GR has sophisticated conflict detection and resolution mechanisms built right in to handle that.
Okay.
However, the default and often simpler mode for many critical systems is single primary mode.
Right, the more traditional way.
Kind of. Only one specific node, the primary, accepts write operations. This simplifies application logic because all writes funnel through that single point.
So you choose based on your needs. Makes sense. How does it handle consistency then, especially with those critical read-write transactions? Thinking banking, e-commerce.
Good question. For those read-write transactions, they only actually commit after the whole group approves it, not just the server where it started.
Group approval again.
Yes. Think banking. Every withdrawal, every deposit has to be confirmed across the board before it's final. That gives you that strong consistency.
Okay. And read-only one.
Read-only transactions, they commit immediately, so you get fast reads without the group consensus overhead.
Got it. Okay, beyond the consistency, the automation aspects sound like, well, a potential game changer for managing databases day to day. What does GR automate? What does it take off a DBA's plate?
Oh, this is where it truly shines. The operational automation is huge. First off, there's automatic distributed recovery.
Recovery, like if a server goes down.
Exactly. If a server goes offline temporarily, maybe crashes, whatever, when it comes back up, it can automatically rejoin the group
And catch up.
and efficiently catch up on all the transactions it missed while it was out. Less manual scrambling, fewer 3 a.m. wake-up calls, hopefully.
Always good.
Uh,
What else?
Second, automatic failover. This is mainly for that single primary mode we talked about.
Right. If the primary dies,
If the primary node fails, GR automatically, and usually very quickly, like in seconds, designates a new primary from the remaining servers.
seamless failover.
Pretty much. Keeps your service continuously available. Absolutely critical for mission-critical apps that just can't afford downtime.
Yeah, you can't have the bank just stop.
Mm.
Okay, what's third?
And third, automatic membership configuration. Adding new servers to scale out your cluster.
Yeah.
Or maybe gracefully taking a server out for maintenance. It's largely automated. Makes managing the cluster, scaling it up or down, much simpler and less error-prone.
That's a massive help for uptime and just reducing the daily grind. But networks aren't perfect. What about network problems? Partitions, where parts of the cluster maybe lose contact.
Absolutely. It's designed for that. GR is specifically built to be resilient against various network challenges, including partitions.
How does it manage that?
It actively works to prevent data loss. The consensus protocol ensures committed transactions are durably stored and consistently replicated across the available majority, even if the network is acting up. It's designed to handle those scenarios gracefully.
Okay, that's reassuring.
Yeah.
And the final piece from people listening, maybe thinking about adopting this, compatibility. And, the big one, cost.
Good points. Compatibility is broad. It's supported on all the major platforms. MySQL runs on Linux, Windows, Solaris, macOS, FreeBSD.
So pretty much everywhere.
Pretty much. And maybe one of the most compelling things, it's completely open source.
Ah, GPL license.
Exactly. Distributed under the GPL. That means no extra license fees, no additional costs, just to use group replication itself.
That makes it incredibly accessible.
Extremely. Very cost-effective, especially for mission-critical applications where maybe proprietary, high-availability solutions are just too expensive. So if you kind of tie it all together, MySQL Group Replication offers this really robust, consistent, highly automated way to deploy MySQL in a distributed, high-availability setup. It's about building database infrastructure that's not just tough, but smart.
So, bottom line, what does this all mean for you, the listener? Well, it means less headache, definitely more uptime, and a much stronger foundation for managing your critical data. And crucially, without necessarily breaking the bank.
Yeah, that sums it up well.
So think about it. What stands out to you about this technology? How might group replication change the way you think about database resilience in your own systems? Something to ponder.
Mm-hmm.
We really hope you found this first deep dive valuable. If you did, please like this deep dive, maybe share it with colleagues, friends who might find it useful.
Yeah, spread the knowledge.
And definitely subscribe to the channel. We need more insights into database tech like this coming your way. We'll be back soon with the next installment in our MySQL Group Replication series.